Hey, today I want to answer to this question: what does a neural network internally? This is a really good question, and before answering it, I want that you visualize what a neural network does and what is. And for doing so, I want to take as example a really simple network composed by inputs, hidden and output layer, so only 3 layers. And let me write the names, and as you can see, each layer has just 1 neuron. We saw in the precedent video that we feed the inputs to the neural network, and the neural network gives us an output. This process is called feed forward. And the execution of the direction execution is this one, is follow this arrow. This means that when we insert an input to this to the neural network, this input travel from the first input layer to the hidden layer, and from the hidden layer to the output layer. But let's see how it's possible this. The first thing that I want to make aware is that each neuron is connected between each other with this link, but this link has also a value, as a W, that's a weight that is indicated with the W, and the weight, this one and this one are chosen randomly. Random. Okay. The idea is that, so the weights of these links are chosen random, and the process is this one. Imagine that we have the number 1, so we submit the number 1 to this input, to this neural network. This input is then multiplied with the weight. So the input is multiplied with the weight between the H and I neurons, and the result we can call it with R. So we can call the result, we can indicate the result with letter R. Who invented the neural network discovered so that our brain doesn't really work doesn't work linearly. In fact, you can see that this equation I multiplied by W is a linear equation, because increasing the value of W increase the value of R, decreasing the value of W decrease linearly the value of R. This means that the neural network can't really work like a brain due to this problem, due to the fact that this is a linear equation. To solve this problem, so was invented the activation function, that are also called S-shaped function, because we can see that all equation, let me use another color for this. So basically, sorry, let me do this better. Basically, what this function does is to take any inputs and squash inside this squash inside the 0 and 1. So it basically take this linear function and commute in a non-linear function. To indicate usually the most simple equation, the most simple activation function are the sigmoid, as is indicated with this symbol. Let me write a bit better. Okay. Sorry. Okay. There we go. So the sigmoid, so the R is then squashed using this sigmoid function, and the result is my X. The X basically is the output of this traveling from the from the input layer to the hidden layer. And now the same process is applied between the hidden layer to the output layer. In this way, we have the X that is the output of this traveling that became now the input of this traveling. So X is then multiplied with W with the weight between H and O that is different from the weight between I and H. So we can call, I can call it O. So I am superscripting my weight with O and H to indicate that is this weight, to differentiate this weight between this weight. The result of X times W, also at this result I have to apply the sigmoid exactly like this function up here, and the result is my Y. So the Y is the result of this execution, of the traveling of this input between these two neurons and then these two neurons. Let's imagine that the result of 1 is 0.3. So I am feeding the number 1, and the result this neural network gave me is 0.3. Also, I was expecting that my result would be 0 instead of 0.3. Let me write here expected. So the expected result will be 0 and not 0.3 as I have here. This means that the neural network should be trained in order to match to give me a number more near 0. And for doing so, there is another method that is called backpropagation. Backpropagation that is executed in the opposite way of the feed-forward propagation. In this way, let's consider always this equation, this neural network. Let's see if I can copy. I hope that it works. Perfect. Okay. I think that there is the possibility to okay, perfect. So let me delete this thing to be a bit more ordinate. There we go. So we have the expected here, and so we have this expected. So the expected is 0. How can we backpropagate and backpropagate the error? How can we correct the this number to become something more near 0, my expected number? first of all, I have to calculate the error, and the error is simply calculated in this way. Expected minus y, that is the output of this neural network, and the result is my error. This means in numbers that 0 minus 0.3, that is equal to minus 0.3. Okay, now I have the error of this neural network, and I have to backpropagate this error in order that the next iteration, when it's fed again the number 1, it gets me not more 0.3 but something near to 0. And how can I do it? Basically, the backpropagation take this error and change the weights, change the value of this weight, and then calculate again the error of this hidden layer, and thanks to the value of this error, change the weight between these two neurons, and so it adjusts the weights in this neural network. This means that the next iteration, basically, instead of obtaining something like 0.3, I will obtain something like 0.2, that is more near to 0. So then I calculate again the error, that is 0.2, and 0.2 I backpropagate again the error of 0.2, and instead of 0.2 then my error will be 0.1. So I reiterate again the error, that now is minus 0.1, and backpropagating this error will make possible that the next iteration will be 0.05. So as you can see, the backpropagation makes sure that my error became smaller and smaller each correction. So this is, we can call it learning phase, learning method. Of course, there are a lot of learning methods, but this is the most simple one. So as you can see, we saw a really simple case, and if you remember in the video that I did before, when I applied the Tic Tac Toe game, the AI in my Tic Tac Toe game, if you remember, I had a really huge brain, because I had 9 neurons in the input layer, 9 neurons in the output layer, and I had 200 neurons in the first input layer, hidden layer, and 100 neurons in the second hidden layers. So the brain was far more bigger. What really changed? What changed between this simple neural network and a neural network that has many neurons and many hidden layers? Basically nothing. You have to imagine that each neuron is connected between each other in this way. So we can say that this neural network is fully connected in this way. And the neuron, basically the inputs are fed in this direction, and the output became in this direction. Then is calculated again the error, and the error is backpropagate in this direction, change all the weights of this connection between them. And yes, that's it, what happens inside the neural network. Now, the idea to answer to this question, what does a neural network internally? I want to show this. This visualization of neural network. This neural network basically does take as inputs all the pixels of this quad, this quad that you can see basically here, and each cube is a pixel, and takes all these pixels and forward to this hidden layer. This one is an hidden layer, and for each neurons you can see all the connection to all the pixels. And now, when using always the feed forward, all this information is forward to the next hidden layer that is again connected to the next hidden layer that is also connected to the output hidden layer. Now, to make everything clear and answer your question, what does neural network internally? Well, the neural network is just a pattern recognition. In fact, it tries to match the pattern and give an output that is more similar to the pattern. Well, let me explain better. This neural network is trained to recognize the pattern of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 number. This means that when I write the number 0, this pattern is created. This pattern make active and less active all these neurons, and these neurons make active and less active all these neurons. Now I can say that more these neurons is active, more is possible that these neurons is the answer to this question, to the question of this image. So I have 0 as image, and I am converting this image to pattern, and this pattern means the activation of these neurons, and these neurons is the neurons that indicate 0. Yes, that's it, really easy. The neural network does a pattern recognition. Now, I want to show you another neural network, the convolution neural network. Basically, I want to show you this one because you can see better in 2D than in 3D, and I want that you see what really does the neural network. Well, these neurons became more active by seeing all these parts of the image. This part of the neurons is more active by seeing this part of the neural network, and so on. But I want to remark that all these execution are not static. So if we take a plain neural network and we start to explain how to recognize these numbers, we will not find this pattern again. So if I write here again the 3, I see again these inputs that are activated, that are more active and recognize the number 3. So I can write a lot of 3, but the neurons are these neurons will recognize the number 3. So what I want to say is that this neural network is trained to recognize this pattern in this way. But if I start this exact neural network with this exact structure, but with a different weights that are applied randomly, the pattern to recognize these numbers will be different. So to answer what a neural network does is that nobody knows what a neural network does, because each neural network, depending on how it is trained and depending on the initial value of the weights, what does change. The cool thing of neural network is that he is able to understand in its own way how to recognize numbers, images, pattern, approximate functions, and all cool things that you can see in the world of neural networks. So the answer to what does a neural network internally, nobody knows. Internally, it changes the weights by learning and give an output following these weights. But nobody really know how this exactly neural network understood how to recognize this pattern and give me this output. Yes, that's it. I hope that you understood what neural network is, and I want again to advise you to search in YouTube the Coding Train channel, and also I want to advise 3 Blue 1 Brown channel that explain really well what neural network does. And also, if you are interested to see and create your own neural network, you can read this book written by Tariq Rashid, that is really well written, that explain the mathematics behind feed-forward and the back propagation of the fully connected neural network. For now, that's it. Thank you. Bye bye.